Good day, and welcome to Group D's presentation on the Pulfrich effect. In this presentation, we would like to discuss the following topics: an introduction to Carl Pulfrich and who he was, an understanding of the Pulfrich effect, the laboratory procedure for conducting, viewing, and measuring the illusion, and an overview of calculating the neural delay time for each group member. Carl Pulfrich was a German physicist best known for his discovery of the stereo effect, which became later known as the Pulfrich effect. The Pulfrich effect is a visual illusion where a two-dimensional, side-to-side swinging motion is perceived as a three-dimensional, D-shaped motion. This can be seen by using a pair of tinted glasses where only one side is left untinted, and looking at a swinging pendulum. This illusion works because your brain uses both eyes for proper depth perception, and when light is reduced in one eye, it results in a delay in your brain's signaling system. The covered eye now sees the motion of the pendulum with some positional delay. This delay then shows us what one's perceived pathway is rather than the actual pathway of the pendulum, as one's brain compares the mismatched signals. Since the basis of the illusion works due to the positional lag in one eye, switching which eye sees through the tinted lens results in the D-shape switching directions from clockwise to anticlockwise or from anticlockwise to clockwise. The aim of this laboratory experiment is to calculate the difference in communication between one's eyes. The material needed for this experiment are a length of string approximately 2 meters, a weight to tie at the end of the string, a pair of sunglasses where one lens is untinted, a tape measure, a ruler, and a pencil. The experimental setup was as followed. The pendulum was set up by attaching one end of the string onto the weight and the other end onto the ceiling, dangling just above a table. 3 meters was measured from the stationary point of the pendulum and the observer. This distance was recorded as distance capital D. The observer put their sunglasses on, and the pendulum was swung in a back and forth motion perpendicular to the observer. A group member was instructed to stand next to the table and move a pen back and forth to estimate where the pen intersected with the arc of the pendulum according to the observer. This distance was measured and recorded as distance D. The observer then switched which eye sees out of the tinted side of the sunglasses. Step 4 was then repeated on the opposite side of the table. The distance between the observer's pupils was also taken and recorded as distance S. The following equations were used to calculate the lag time between one's eyes. When calculating for the distance, it should be noted that each group member has a different calculated distance, with the average being 0.252 centimeters or 0.25 centimeters. The individual distances were taken and used to calculate each group member's lag time. Since the distance was unique to the individual, so are the lag times. The following clip demonstrates what this experiment should look like. It can be concluded that each person having a unique delay time is due to it not being a constant, as it is a measure on how much one's own eyes are delayed, which is unique to the individual. In this group, the total average delay time was found to be 0.03 seconds. Thank you for listening to our presentation.